That covers the number of reservoirs that are needed. Now we'll have a look at differences between mechanical and natural ventilation. A natural ventilation system uses the buoyancy of the smoke to provide the driving force for exhaust. The rate of exhaust is largely dependent upon the depth and the temperature of the smoke. The advantage of a natural ventilation system over mechanical is that it is very simple and reliable, and it can cope with a wide range of fire conditions. In the event of a fire exceeding the designed fire size, for whatever reason, the exhaust rate will increase due to the smoke layer being deeper and the smoke being at a higher temperature. Furthermore, the base of the smoke layer will descend, so less smoke will enter the smoke layer due to less entrainment of cool air. In other words, the system is to some extent a self-compensating mechanism. It's designed so that the amount of smoke leaving the ventilators when the smoke is at its design height is equal to the smoke entering the layer from the plume. Mechanical ventilation is where there are electrically driven fans located at high level in the reservoirs, and these come into operation on detection of smoke within the reservoir. Only the fans in the fire-affected reservoir operate. Fans in reservoirs unaffected by the fire remain dormant. The fans should have duplicate power supplies so that failure of one supply will not stop them from functioning. The fans are designed to be capable of removing at least the same amount of smoke that is entering the layer when the base of the smoke layer is at its design equilibrium height. How does a designer choose between natural and mechanical ventilation? Well, if natural ventilation is possible, then the designer is likely to adopt this approach, as it's cheaper and simpler than mechanical extraction. However, there are a limited number of circumstances where natural ventilation can be provided, and these are as follows. 1, when the clear layer height is not excessively large, as large heights of rise tend to lead to low smoke temperatures. 2, when there is no building above the reservoir, and the top of the reservoir is simply the roof. 3, when the wind over and around the building is likely to create a negative pressure above the vents and not a positive pressure. For this to be the case, we would normally expect to see a flat roof or a low-pitched roof of less than about 30 degrees from the horizontal. 4, when the building is not closely surrounded by buildings taller than it, where wind pressures might produce positive pressures above the roof and above the vents. And 5, when the clear layer height does not exceed Z max. In circumstances where there is doubt over the feasibility of natural ventilation, the designer can either run a CFD model to try to demonstrate compliance, or he or she can opt for mechanical ventilation. The circumstances where mechanical ventilation is likely to be required are as follows. 1, when extracting under the balcony in a divided building. 2, when carrying out slot extraction at an opening. 3, when positive pressures might be present above a roof. 4, where the exhaust points are higher than Z max, the highest height that we can expect smoke to attain. 5, when the smoke temperature is particularly low. 6, where the exhaust points cannot comply with the 20-metre/10 metre rule for ventilator spacing. 7, where there is doubt about the feasibility of natural ventilation. That covers the principles of mechanical ventilation and the situations where it must be applied rather than natural ventilation. Now, before we move on to determining the required sizes or capacities of exhaust points, we must mention the rule for separating ventilators in neighbouring reservoirs. In natural systems, the ventilators in neighbouring reservoirs must not be within 6 metres of each other, as shown here. This is because smoke leaving one reservoir may be drawn into a neighbouring reservoir, thus spreading the smoke around the building. As long as the separation distance exceeds 6 metres, it is deemed very unlikely that smoke leaving the affected reservoir will be drawn back into an unaffected reservoir.